Hello students, how are you all? Hope you are safe at your homes and healthy. So our next topic for today is electric power. What is power? First of all, we all know power is nothing but the rate of doing work, right? But we have to study electric power here, and electric power will be defined as rate of electric energy which is dissipated or consumed in any electric circuit. As we have studied in the previous lectures, that electric circuit, in any electric circuit we are having a current flow, and whenever current is flowing, what happens, it dissipates energy in the form of heat, right? So regarding that, we can calculate, or we can find out some mathematical expression for electric power also, right? Mathematical expression to be found with the help of the basic power formula. What is the basic power formula? We are having basic power formula as P is equals to W upon T. What is W? That is work done. T is time, which is rate of doing work. Okay, now work done is equivalent to energy that we have understood in our previous lectures, and here I'm using that concept, work done when equivalent to energy. That means it is what type of energy we are considering. We are considering heat energy, heat dissipated. Okay, so W can be replaced by H here, and it will become P is equals to H upon T. Using the heat energy formula, that is H is equals to VIT, H is equals to I square RT, and H equals to V square over R multiplied by T. These three formulas we can use, and we can find out the new expression for electric power. So first formula we are using over here, that is H is VIT. T is cancelled over here, you can see, and power becomes VI. V is the voltage or electric potential difference across any conductor, and I is the current flowing through it, right? So this is the first formula for power. Next is using other equations of heat, we can find out over here power is equals to I square RT divided by T, that is power is equals to I square R, right? This is the second formula we are getting, and similarly we will get power is equals to V square over R. These are the three formulas that we have got for power, and these three formulas will be used in numericals very soon when we will discuss numericals based on electric power, right? Now what is what is the unit of electric power? That is again the same, that is watt. Power, we know the unit is watt, so electric power is also having the same unit as watt, and it is represented by capital W. The larger units we are using nowadays, electric power is used in large quantity, so larger units are kilowatt, or it may be megawatt also. Megawatt is megawatt. Megawatt is M, capital M W, right? It is equivalent to 1 megawatt is equivalent to 10 to the power 6 watt, that we can see. Okay, now what is 1 watt? As we have defined 1 ampere, 1 ohm, and 1 volt, similarly we can define 1 watt over here. It is nothing but the power consumed by a device that is carrying 1 ampere of current when operated at 1 volt of potential difference. It is written according to the basic formula of P is equals to V into I. P is power 1 watt, and V is 1 volt potential difference, and I is 1 ampere of current, right? Next comes related topic is electrical energy consumed. Electrical energy, whatever energy is consumed in our houses, that is related to this topic, that is electrical energy that we are using in our houses using electrical meters, right? The formula for that will be E is equals to P multiplied by T. It is nothing but the similar formula, that is P is equals to W by T, and W was replaced by the energy in the previous, on the previous page we have done it, right? So P is equals to W by T, so W was replaced by energy, that was heat energy, and here I am considering it as a electrical energy, so W was replaced again with the energy only. So E is equals to P multiplied by T, it becomes. This is the basic formula for electrical energy consumed, right? What will be the SI unit for energy? SI unit is the same that we have used every time in the previous classes also. SI unit of energy is nothing but it is joule, and here because it is related with power and time and it is electrical energy, so it will be power is SI unit watt and time is having SI unit seconds, so it may be written as watt second over here in this case, right? Now what is the commercial unit of electrical energy? This topic I think we have done in class 9th also in the work energy chapter. Okay, so you must remember that commercial unit of electrical energy was kilowatt hour. kWh is the symbol that we are using for it, and kilowatt hour is also known as a unit, that is the energy consumed by all of us in our houses or in our any commercial places, right? Next comes the definition for it. What is, how we will define electrical energy consumed? It is defined by it is defined as an energy consumed by any electrical appliance which is equal to product of its power rating and the time for which it is, that device is being used, right? SI unit will become joule, that we have understood earlier, and the other unit that is given in your book very importantly is watt hour. Hour is the time. Time is not having our SI unit over here, and power is having SI unit. So watt hour is some other unit. We cannot consider it as a SI unit, and we cannot consider it as a commercial unit also, right? So watt hour can be defined here. 1 watt hour will be that energy when 1 watt of the power is used for 1 hour. Energy consumed by a device when 1 watt of the power is used for 1 hour. For example, if we are having a device, a bulb, a small bulb, a small bulb of 1 watt, so we are using it for 1 hour, so it will consume how much energy? It will be consuming 1 watt hour of energy, right? This energy we can convert it into joules also. This energy we can convert it into kilowatt hour also, that as we know. And the relation, next is the relation between kilowatt hour and the joule. What is the relation? 1 kilowatt hour is 1 kilowatt multiplied by hour. 1 kilowatt multiplied by hour, because this is power and this is time, right? So kilowatt can be converted into SI unit. Why? Because we are converting kilowatt hour, that is commercial unit, into joule, that is SI unit. We want to convert and we want to find out the relation. So what we will do, we will consider 1 kilowatt as SI unit. So it will be 1000 watt, and for hours, we will convert it into seconds, that is SI unit for time. So 1 hour is equals to 3600 seconds, that we know, right? So it will become what? It will become watt seconds. Watt seconds. Watt second is the unit of SI unit of energy we have discussed, right? This is watt second or joule. So watt second can be written as joule. We have written it as joule. And how much it is? It will become 3600 multiplied by 1000. So it will be 3.6 multiplied by 10 raised to power 6. 1, 2, 3, 4, 5 and then 6. So this will be the figure that will be using for conversion of kilowatt hour into joule. So what is the basic relation which is very important is 1 kilowatt hour is equal to 3.6 multiplied by 10 raised to power 6 joules. This is a relation which is very important for numerical purpose, and here we can consider 1 unit. It can be written as, it is equivalent to 1 kilowatt hour is equivalent to unit, so we can also write 1 unit equals to 3.6 multiplied by 10 raised to power 6 joule. That also we can write. Okay, that's it. This is the last topic for this chapter. I hope you understood all the topics. If any queries, you can contact and then ask your doubts. Please read this, read the whole chapter, in fact, from your NCERT book, and then come with your queries. Thank you.